Hi, and welcome to the second part of the OriginPro 8 tutorial. Now we have the basics of the OriginPro ready, and we know how to input the data, how to create and manipulate a graph, and fit it with the desired fitting function. Now let's put all these skills to a test in an exercise. In this exercise, we will open a file with a spectrum that contains 2 iron 55 peaks. The data file is provided with a module. And what we will do in this exercise is we will plot the data, we will fit 2 Gaussian peaks on the same graph, extract sigmas with errors, and make the graph into a publishing quality figure. To begin, open your project in your OriginPro 8. You should see a workbook 1 open, and that's all we need for now. Let us import the data. OriginPro 8 has a great import wizard that allows you to import data from many different types of files. The file you downloaded should be in the .spe format. In order to import a file, let's go to File, Import, Import Wizard. And here an Import Wizard window will pop up. Here we could select our data type, whether it's an ASCII, a binary, or maybe you have something you want to find, the data source, etc. And we are not interested in any options here. So let us open our file, just here, and press Add Files. Using the Add Files function, you can add many files at the same time, and each of the file will, the data from each of the files will be put in a separate worksheet, and a workbook basically will be created for it. Okay, so that's okay. And press Finish to close the data import. There we go. We have our data in Workbook 1. Now, our data is put into 2 columns. The first column actually contains the spectrum we're interested in, while the second column only has one value, which corresponds to the channel number, but it has no relevance here. So, let us copy our data, cut our data from the first column to the second one, so it will be shown on the y-axis, as I mentioned here before. So right-click, cut, second column, select, paste. There we go. However, we will not be able to plot our data without an according x-axis. So let's fill in the x-axis with row numbers, as we have done before. Okay. And now we are ready to plot our graph. To plot the graph, select both columns, right-click, plot, symbol, scatter. This message says that there's too many data points to show at the same time, so we're not interested in it. Okay, and here's our spectrum. The data is quite squished together, and we will not be able to select what we want to from this. So let's zoom in on the both peaks. Okay, so double click on the x-axis, scale, and let's select our origin at 2000 and the final 3000. Let's click apply, close, and here we go. We have a much better image of our peaks. Okay, to fit these peaks, we will use a Gaussian fitting function. In order to do so, select the data you want to fit, press Analysis, Fitting, Nonlinear Curve Fit, and Open Dialog. A nonlinear fitting function dialog will appear, this window, where you can select what kind of function you want to use to fit the data. Here in the Origin basic functions, you can access the most commonly used ones, such as Gaussian, logarithmic, exponential decay, sinusoidal, etc. However, there are many other categories that contains even more functions that you might be interested in. However, we're only interested in Gaussian in this case. Since we have 2 peaks in our spectrum, we want to select the data range to be around 1 peak for the fitting function not to be messed up because of two peaks happening here. To do so, we go to Data Selection tab here, and at the end of the input data here, we press on the arrow, and we select all data from the graph. Press here, and now we're brought back to our graph. Holding the left mouse button, we can select the data range we want to be included just for our fitting. So let's select here, and let's go back to this fit here, and here we go. Now we only selected our data to be from 2114 to 1400. Doesn't matter whether the value is specific or not. Now if we press Fit, our fit will try to converge. Okay, and yes, we want to open the forge. So here we have the values from our Gaussian fit. Okay, let us close it to see how it looks like. And the table is in the past with the linear fit. And here, as you can see, our data is fitted pretty well with the Gaussian. And this table contains the main information we're interested in, such as our height, the position, and the sigma as well, and the full width maximum. That's it. We can export these values directly, or we can find them in our worksheet here, as well as the raw information again is written in the fit nonlinear curves one. Okay. Now, let us fit the second peak. Let's minimize this slightly. Okay, so we select our data again. Analysis, fitting nonlinear curve fit, open dialog. And now let's select the data to be just around the second peak. Okay, we select the data and the small peak. Okay, click here to select the data. And let's press fit. Okay, we can do this now. Here we go. So a second table is provided. That shows the information of the second peak. As you can see, the XC values are different, which shows the center of the peak. Finally, let us tidy up the graph. Because our axes are not showing the full picture, they have no labels, we don't know what we're looking at, and our legend means nothing as well. Okay, so first of all, let us alter our x-axis. Let's go on the scale, and let's include a bit more, so you can see how our tails are. So let's go 1500, and let's change our increments because they're way too coarse. So let's do this to 250. Click apply. There we go. We can also change the name of our axis. So double clicking on the name, and let us change it to be ABC channel number. Okay. Now also let's fix our y-axis because it starts not at 0. So double click, scale, and change from -100 to 0. Click OK. There we go. And let's also change our label on y-axis to be number of counts. Okay, that's already much better because we know what we're looking at. Thirdly, let us change the legend. So you can select the legend if you move it around directly. But if you double click on any specific symbol here, it will alter the description behind it. So our data itself is an iron 55 spectrum. The first fit is the 5.9 kV Gaussian fit. And let's include our value for sigma for it, which is 23. No, sorry, let us include actually full high maximum, which is full width half maximum of 54.2. And let us change the second peak's fit as well to be a 6.6 kV Gaussian fit, and the full width half maximum is 55.4. Okay, and this way we can make sure we contain the main parameters on the legend, and we can delete these tables. And the final thing to include here is to make our fits more visible, because if you would be presenting this in front of a large audience on a large theater with a big screen, you will not be able to discriminate the black from the red. So to do so, we select our fitting lines, double click on them as before, and let's increase our width to 3 and make this one red. Yes, click apply, close. Here, now it's much more visible. And let's change the color on our smaller one as well. So let's switch from red to bright green, and let's increase the width as well. Okay, click apply, close. And here we go. So we have imported the data, fitted it with 2 peaks at the same time, and polished our graph. This will end the tutorial, the basics of Origin.
So again, this won't plot automatically, so I need to do a replot, but instead I'm going to type rep, R-E-P. Does the same thing as replot, it's just shorter. And there we go, we now have a nice